Hello everyone, and welcome to our 12.4 notes on scatterplots and lines of best fit. This is our last lesson of the year, so congratulations, you've made it. So today we're going to look at scatterplots. So what is a scatterplot? If you have ever spilled a box of rice everywhere before, you know what it means to scatter. But in statistics, a scatterplot is going to have points that show the relationship between two sets of data. In other words, a scatterplot is going to be done on a graph, and that graph relates to groups of data. Scatterplots are used to plot points on a horizontal axis, which of course we know is the x-axis, and a vertical axis, which of course we know is the y-axis, in an effort to explain to what extent one variable is affected by another variable. The relationship between these two values is going to be called their correlation. So it just tells what you have two variables and it says the correlation between them. Of course, correlation has the word relation in it, and so it's going to be the relationship between two variables in a data set. Relationship. Okay. Then we have something called our correlation coefficient, which we're going to look at in a little while. It is going to measure both the strength, how strong the relationship is, and the direction, whether it's positive, negative, or no correlation. And the R is going to be between -1 and +1. So another way to write that would be -1, R, +1. All right, so what is positive correlation? Positive correlation is where you plot your data on the X and Y axis, and it makes this positive slope. These are not a perfect straight line. The closer it is to a straight line, the stronger the relationship and the higher your R value. As far as getting closer to 1, the further apart these are, the weaker the relationship. And so if R is positive, it is going to be greater than 0, but less than or equal to 1. The closer to 1, the stronger the relationship, and then the tighter the line would be. Then you have the negative relationship where R is negative, so less than 0, and greater than or equal to -1. That's where R is negative. This gives me negative slope. The closer it is to -1, the stronger the correlation. So like a -0.96 relationship for the R value, correlation value, is going to be stronger than -0.25. And then we have where we have no correlation at all, which is where the data is just kind of scattered all over the scatter plot. That's where there's no relationship and R is 0. All right, so let's review real quick. We learned about positive correlation. So positive correlation is when an increase in value of one variable increases the value of the other variable. So as X increases, Y increases. Okay? All right, then we have a negative relationship, negative correlation. The negative correlation is where an increase in one decreases the value of the other. And then we have no correlation, where there's no linear dependency, so meaning it does not make a straight line between the variables, so it's just kind of scattered everywhere. And so what we're going to do on this next set of problems is determine the correlation of each scatter plot and estimate the R value. So let's look at this first one. This first one seems to have a positive relationship, but it is pretty spread out. So I'm going to write positive, and we'll come back to the R value later. Okay? This next one is all over the place. This is totally scattered, so we're going to say no relationship, no correlation. R is going to be about 0, really, really close to 0. All right, and then we have our first negative relationship example. And my R, goodness, negative. My R is very, very, very strong here, so it's going to be really close to -1. So maybe it's at like -0.89 or whatever it is. That one's going to be much closer to -1 than it is to 0. So very, very strong negative relationship because that's almost a straight line. And then we have another positive relationship, but number 4 is a little bit more strongly related than number 1. So I would say it's still positive, but it's going to be closer to +1 than number 1 is. So like maybe number 4 is like 0.75 and number 1 is like 0.34, okay? And so I'll show you how to calculate R values, and we'll learn how to do that on our computers. But that is just overall looking at scatter plots and determining if there is a positive correlation, a negative correlation, or no correlation. The back of the notes is where we start talking about causation, which is different. Causation is going to be when something causes something else to happen. So when we look at correlation versus causation, here's what it says. When two variables are in fact correlated, so if we know for sure that they're correlated, we know that there's a relationship between them, that does not necessarily mean that a change in one variable causes a change in the other variable. We would have to have a control group to prove causation. So let me just give you an example. If you looked at the number of ice cream sales and the number of shark attacks. If we looked at the sale of ice cream versus the number of shark attacks. I would say overall, shark attacks, that there would probably, as the sale of ice cream increases, the number of shark attacks would probably increase as well. Does that mean that the number of shark attacks is caused by the sale of ice cream? Absolutely not. There's another factor, the temperature or the time of year, that is allowing people in the summer to buy more ice cream. And also more people are in the water, more people are going on vacation, so more people are getting attacked by sharks. So that would be an example of correlation, but not causation. So correlation, let's learn a little bit more about it. Correlation is going to be a statistical technique which tells us how strongly the pair of variables are linear related and change together. But here's what it does not tell us. It does not tell us the why and the how between the relationship. It just says that it simply exists. So it doesn't tell us the why, it doesn't tell us the how, it only tells us that the relationship in fact does exist. So we have an example, and it's very close to what we just talked about. Correlation between ice cream sales and sunglasses sold. As the sales of ice creams is increasing, so do the sales of sunglasses. So they both increase. As the number of sunglasses sold increases, so does the ice cream sales. But what might be something that is a factor that is causing both, sorry guys, the sale of ice cream and sunglasses to increase? That is going to be like the temperature or the time of year. So there is in fact a positive correlation here, but we would not say that this is causation. One does not cause the other to happen. So now we're going to look at lines of best fit. So line of best fit is going to be a straight line that represents the data on a scatter plot in the best way. This line may pass through all of the points, some of the points, or none of the points. The line of best fit is also known as the trend line. And to draw a good line of best fit, we want the same amount of data on each side of the line. So we're not trying to create a line that goes through all of these triangles. Of course, that would be very hard to do. What we're trying to do is get the same number of triangles above the line as I have below the line to be a good representation of a trend line for this information. And so we're going to actually start that by creating one. And so the table at the right gives the number of hours spent studying for a science exam and the final exam grade. So it wants us to draw a scatter plot first and then draw in the line of best fit. Okay, so we're going to estimate this. And so we've got our graph. So we would make our x-axis, our x values, would be the study hours. And then our y-axis would be the grade on the test. So we're not going to do this perfectly. We're just going to we're going to plot them real quick. 384. 3 hours is 84 on the test. Somebody got a 77. The person that studied for 5 hours got a 92. The person that studied for 1 hour got a 70. The person that studied no hours, 0 hours, got a 60, so they showed up and passed the test. The person that studied for 4 hours got a 90, so this is looking pretty much like a straight line so far. And then the person that studied 3 hours got a 75. And so this is not a perfectly straight line. If I were to draw this in, if I were to draw in a trend line, I'm trying to get the same amount above the line as I have below the line. Maybe do something like this. This is not a perfectly straight line. You can see that. So when you draw in a trend line, there's going to be some human error. And so it says, draw a scatter plot of the data and draw in the line of best fit. So you're going to do that on your own sheet of paper. And then it says, what is the equation for the line of best fit? So what we're going to focus on in this class is picking a trend line to match data that's given. So when you find the equation of a line, we know it's y equals mx plus b. What you're going to do is you're going to first decide, should your m be positive or should it be negative? So since this is positively correlated, we know that we should have a positive slope. So when I fill this in, I should have a positive slope. And then my y-intercept is going to be my b value. So we're going to guesstimate based on our trend line, what was our y-intercept. So our y-intercept was just a little bit above 60, maybe somewhere around like 61, 62, maybe 63. So I might just say plus 63. What is my slope? Well, my slope looks like I'm going up about 8 from my grade, up about 8 and then over 1. So I'm just going to kind of guesstimate positive 8x-ish over 1x plus 63. So that just means my grade goes up about 7 or 8 points for every hour that I study is what it looks like. It goes up 6 or 7 really is what it more looks like to me. 6 or 7 maybe. So maybe we'll go in the middle and go 7. For every 7 points I go up, I study for 1 hour more. And so we're just looking at the slope there. So this is just a guess. This is just our guess based on the just the graph that is shown. But now what I'm going to show y'all in class is a calculator. I literally just Googled, and you can do this on a graphing calculator too, line of best fit, and I typed in that data from before. So I typed in those points, 384, 277, 592, 170, 0, 60, 490, and 375. And I clicked enter, and it gave me this line of best fit, the best fit values, and it even gave me a line of best fit and graphed it for me. So this looks very, very similar, and you can see they have a y-intercept right here of 62 plus or minus 2.632, and then the slope is about 6.3. So we were really, really, really close, y'all. And so what we're going to do is we're going to write that down. So about 6.3 plus 62. So let's see how close we were. The actual calculated, so I'm going to do the calculator online, was y equals positive 6.3x plus 62. Okay, so the equation would be 6.3x plus 62, where you can tell my correlation is positive, so is my slope, and then my y-intercept is going to be 62, which is about where I crossed the y-axis. So it says predict the grade for a student who studied for about 6 hours. So you could either use the equation or you could predict it based on your graph. For about 6 hours, I would expect that student to get pretty close to a 100. So you could even plug it in, y equals 6.3 times 6 plus 62. So let's go ahead and calculate that. 6.3 times 6 plus 62 is going to give me 99.8. So somewhere around really, really close to 100. So we know that in geometry, lines can go on forever. If it's called a trend line, we know that geometrically those go on forever. But realistically in our situation, would it make sense for this to go on forever? We would say no, because number one, you have grades do not go on forever. So you have a maximum amount of grade points that you can get, even if they have a bonus that tops out eventually. You have a max amount of grade points, and there are only so many hours in the day. So you can't study forever for a test that has a deadline. So there are only so many hours in a day to study. At some point you have to sleep and eat, and at some point you just have to take the test. Okay? So while it is a trend line and we can make predictions, you know that the grades eventually top out and the time spent studying will eventually top out as well. And so your assignment is a Google form, and you will practice matching trend lines to the appropriate data, and then you will also talk about positive, negative, and no correlation, and then the strength of the R value.